Hello, I'm Mike Walton, the owner of Lostock Junction Railway. This presentation was made by myself and Keith Martell, one of the operators. First of all, we need to go through a description of how the layout is designed and built in order to understand how we run to a scheduled operation. Starting with an overview of Lostock Junction Railway. This is the area where I was raised before emigrating to Canada. It's an area of mixed attributes. It's a mixture of glorious scenery and heavy industrialisation. Lostock Junction isn't a complex layout, it's simply large. I operate British stock, German stock and some Canadian stock. There is a simple large layout with a network, and all the traffic is conducted in and out of Windermere. In some way, it's just like operating a company. There are protocols to be established, and we rely heavily on operators who are very skilled. At the end of the day, the objective is to have fun. The electrical system is not complex. I have stayed away from DCC. We find that DC serves the purpose better. The system is designed to be intuitive and to allow operators to come up to speed to work the different sections effectively. It's a very reliable system. Apart from this, we have the more complex signalling system. This is designed principally to operate the signals and to indicate track occupancy. A failure of this system will not stop us operating. My wife doesn't want anything to do with the cellar, as she calls it, which suits me fine. It's been a long time in development, but has seen a couple of layouts in the process. It's an ongoing process, and you'll see that we really have had a lot of operating sessions. We'll start by describing Windermere. Windermere itself, the prototype. It's relatively new in its day, but it never really got developed any further than Windermere. There was serious opposition to it by famous people like William Wordsworth, stood up in Parliament and objected to its progress. He was also joined by the such of Beatrix Potter. I have my mixed feelings about whether putting a railway into such a scenic area is a good idea. However, there it is. This is Windermere Station, and this is as far as the railway got. A friend of mine suggested Windermere, and it's worked out to be a wonderful choice. Similar to Canada, the Lake District, the railway promoted tourism. When you model Windermere, you realise quite how large it is. It's 21 feet long, and it's pretty well an exact replica, although there is a slight bend to the model to get it into the space. Windermere never had a engine shed. This is a replication of the LMS turntable, and the coaling facilities are actually at Carnforth, but for convenience, we have relocated a bit of Carnforth to Windermere. Don't be confused by the coloured bits, those run under Windermere, and to all intents and purposes the Windermere operators have nothing to do with them. It takes 5 operators to run it fully. The more operators you have, the more smoothly you can operate it, and the more prototypical you can work. The control panel, there is nothing really magical about this. The wand is used to select the blocks. In the centre there are 4 controllers. You can see underneath Windermere are the return loops. We actually worked to the 1953 timetable. One of the operators spent some time and is very enthusiastic about this, which all served to our advantage. It's very simple. You just look at the real timetable as to what time the trains arrived in Windermere, and you look at what time the trains departed. This information was loaded into an Excel spreadsheet. At the start of scheduled operation, we didn't actually work to a timetable. All we did was work to sequence, and as we developed the skills and technology and the concept, we moved to actual working to the clock. The operator's instruction sheet is kept deliberately simple. We have removed the amount of we have just put in the information required to run the railway. The trick is to setting the time between operations. If you're an industrial engineer, you're probably familiar with the concept of rate items. Well, the rate item here is 5 minutes per operation, and so you step through the timetable in 5-minute increments, although in reality you may see a difference of 1 hour and 20 minutes. So the operators look to the left hand column to see what time it is, and then determine whether if there's a train arriving or a train departing at that time, to where it's going and what platform is allocated. You can check on the platform availability. In some cases you don't want to, for operational reasons you may choose to change the platform assigned. It's interesting perhaps to note here that A is an express train and the long trains. B is generally a shorter train, 5 carriages. The local train can be 3 carriages. F is a goods train, and a light engine is a convenient way to actually reverse an engine that goes around the network, often backwards. Some of you are familiar with string diagrams for scheduling, and if you turn the timetable sideways, this is in reality what you have. So how does the day run? Well, we start at around 10 o'clock, and by 10:35 everybody's got themselves in order and the first train arrives in Windermere. I then put the kettle on, and then lunch break, everybody emerges from the basement to our brown bag lunch. And then operations generally finish right on time at 2:15. So we get an assortment of trains coming into Windermere. The Windermere Express actually had about 12 carriages when it left London. Coming into Windermere it was down to about 3 normally. The key is to obtain a good balance between boredom and overexcitement, and that's what scheduling does. Good scheduling will keep everybody pleasantly engaged. As I mentioned earlier, all goods traffic operation is conducted at Windermere. Unlike North American layouts, which have way freights, all the trains arrive and depart, all the goods trains arrive and depart from Windermere. Now then, how we get variation into this schedule I will explain. First of all, we took a selection of goods wagons to make it representative of the traffic of the time. We then loaded those 60 wagons onto a spreadsheet and then broke them down into various trains. In fact, there are 12 different trains, and each train is different, a setup of a combination of those 60 wagons. Each wagon has a location where it belongs on Windermere. The Cattle British Railways with one black dot belongs in siding number 5. It is picked up there and returned to there. This table here, you can see, for example, that the LMS cattle wagon with one dot starts out life on train 1, then goes into the yard for 2 days, and then comes out on Thursday, and then returns Tuesday, and then returns on the Thursday. Then it's back in the yard. So you can see how that same wagon goes out on trains 1 and 7. There are 12 cards here. We put out 4 for every session. 2 cards for the arriving train and 2 cards for the departing train. This shows how we go through a day's operation. In the morning, trains 1 and 2 might be put onto the layout. In the morning, train 1 comes in and train number 5 goes out. We repeat the same in the afternoon. 2 comes in, 6 goes out. At the end of the day, trains 5 and 6 are returned to the cassette and remain there for another 2 months until 2 sessions later when they come out again for reworking. So this actually results in a 6-month cycle. Trains 1 and 2 coming off the cassette on session 141 and also coming out on session 147. To add a bit of authenticity, this is posted on the wall, and it shows that for this particular day, which is a Saturday, train 11 arrives in the morning at 9:50. This is the time of day as it would be at Windermere, not on the clock on the wall. The long goods trains were quite an interesting challenge. First of all, just bringing such a train into Windermere is quite a challenge, and then the process by which we reshunt them and send them back out again is interesting. So we've talked about Windermere so far. So Windermere basically supplies and absorbs trains. From Windermere they go onto the network. The network is representative of the line between Settle and Carlisle. It was one of the last main line railways built in Britain. It goes through some spectacular countryside. So, this is, I think, one of the most beautiful viaducts on the line, which is why I modelled it. This is the Windermere, the Arton Gill viaduct on Arton Gill. Here we see a Midland engine with a goods train passing over it. There's quite a lot of work in building this. It took about 12 months to make all this. I deliberately avoided putting too much scenery onto the layout because it really doesn't look like the scene. You don't have many houses on the Settle-Carlisle Railway, just masses of iconic countryside. However, at the heart of the network is Lostock Junction. Lostock Junction was close to where I lived. This actually looks a bit like Lostock, but it was not. Lostock wasn't anywhere near as complicated. Here you see two trains arriving from the loops. The first one is coming from Wigan, and the second one coming from Horwich. On the main line there you will see a train going round, two trains going round and one up the hill. Take note here, the scenery is supported on a steel stud structure. Initially the layout was built on a wooden structure, but it tended to sag over time. The metal studs have been remarkably stable. This is probably a unique feature of the layout. I don't have storage sidings. I don't have room for storage sidings. Essentially what I have are 17 storage cassettes which lift in and out of the loops, so any train can be inserted into any of the return loops. We did play with systems for lifting these out mechanically, but in the end I found I could lift them out cautiously in and out of position, and it was a simple way of doing it. When we go on to network operation, this gets very, very interesting and exciting. Fundamentally, trains circulate around the network until required in Windermere. There are gentle grades and generous radiuses, but it's a long way round. It's a bit like juddling. You have, with 14 trains, up to 14 trains on the track, each operator can end up operating 3 or 4 trains, and it gets very exciting at that point. We'll follow a train through from its start at Windermere. The train leaves Windermere, it then passes over to the Blackpool operator. It then goes down the hill under the control of the downline operator, Arton Gill Settle, Lostock. It then moves over to the Bolton in the loop operator, Bolton, Kersley, Bleemore. It then passes over to the Wigan operator, and he passes it back to the inner loop operator, Bolton, Bleemore, Kersley. Then it goes to the upper line operator, and it goes Lostock, Settle, Arton Gill, and back to the Blackpool operator. Right, the Blackpool operator has the option then. He can send that train into Windermere, but more often than not he returns it back down, and this cycle repeats itself. However, if you don't wish to go the long way round, you can go the short way through Horwich. So when reaching Lostock Junction, he goes straight ahead, taking the short route via Horwich, back up the hill again through Lostock, Settle, Ardengill and back into Blackpool again. The layout sits at a very convenient height. This is the original crawl space height where the operators sit. In the centre is this is minimum stuff, I would say, with 3 controllers. Often we try to put more operators in there to get better control. It means that you run the trains more realistically with acceleration and deceleration rather than sudden starts and stops. Below you can see the train on track indication and the clock that they use to time the trains. The panels are intended to be as intuitive as possible. Originally we had 2 or 3 controls and block control, but that was too complex. One of the operators said this is like flying an F-15 fighter. So essentially we kept the controls to a minimum, and the controls, the stick controls there, if you like, keep matters simple. If all those are set to 70, the trains will all run, and you can adjust each train individually to catch up or slow down with the one in front of it. Below the panel you will see the TOTI, the train on track indicators. Each is set for the appropriate controller underneath, so you can see that section A on Ardengill is occupied. Above the occupants thing you can see the signals, and these are used to indicate the setting of the semaphore signals. You cannot see the semaphore signals. In actual fact, the operators don't use the signals. They choose the direction of the train, and the points change and the signals change correspondingly, depending if our section is occupied or not. Blackpool operator's control panel is very similar. He takes a train from Ardengill and sends it either through Blackpool and back down the hill again, or he directs it into Windermere. He has probably got the most busy man. He's probably the busiest operator on the layout. The Wigan-Horwich operator panel is very similar to the Blackpool panel. He has train on track indicators, signal indicators. He also has some simple block selection opportunities. To the right hand side you will see he's got a more refined, more detailed train on track indication. You can actually see the length of the train on that. He's got 2 trains in the hidden sections there. Behind him he's got some other trains coming around, and to see those he's got the rear view mirror. We prefer to use direct vision where possible because it's more easily understood than the indicator system. You can actually see the speed of the train and whether it's actually moving. So, really, operating the layout to a schedule is simple. Well, I said it was simple. Knowing what you have to deliver and delivering it on time should be a piece of cake. However, things do go wrong. The operators are often overloaded and they don't have time to read the watch. Here we have a picture of Preston Control Centre, as it was probably around 1953. The Windermere traffic controller works with the Windermere and Blackpool operators, and his job basically is to get the trains out on time. Sometimes he actually drives the train out, and we have a high degree of flexibility in the way people work. Here we can see the Windermere Operators Station, Windermere Traffic Controller Station. There's a convenient shot to show the pit, which was dug into the crawl space. You can see that we have given the Blackpool operator a chair with no wheels, because we don't want him disappearing into the hole. The network traffic controller, sometimes we combine the job of network traffic controller with Windermere controller, but basically if the network traffic controller stays in the pit area and helps the pit operators, this shows the train on track indicators on the panel. It's useful to the network operators to see which tracks are occupied, to determine which is perhaps the best way to route a train back to Windermere. For much of the time, the pit operators are focusing on the action at Lostock Junction, and they don't have eyes in the back of the head to see what's going on behind them. What can help the network traffic controller can help and see when there are problems occurring, or if there's likely to be a problem. He can also alert the Blackpool operator that he has a train coming up the line which is due for entry into Windermere. After 60 years tinkering with trains and a little help from my friends, I think I've finally achieved something which feels like a real railway to run.